In this problem, we want to use mesh analysis to find this current I. Of course, the first problem always is to determine our mesh loops. Probably the most rigorous way to do that is to kill our sources and then find any resulting enclosed non-overlapping areas. So killing this current source becomes an open circuit. Have a resistor there. The voltage source becomes a short circuit. And another resistor here. This is our only enclosed area. This hole in the side makes this not a choice for a mesh loop. So I'm going to define a single mesh loop going around this side. It's going to be I1. Now I have to pick my constrained loops. Constrained loops will go through current sources and they have to match the magnitude and the direction. I have only one current source. I need only one constrained loop. I'll rather arbitrarily put it around this side here. That'll be 18 amps. That now accounts for this source. Now I just have to do KVL around my single mesh loop. So starting down here, I see the negative terminal of the 5-volt source first, so minus 5 volts plus the 20 ohm resistor multiplied by its current. I have I1 going this direction, and I have 18 amps going in the opposite direction, so that's going to be an I1 minus 18 amps. And then we have a 10 ohm resistance, and the only current through that is I1. That brings us back to our starting point, so all that sums to 0. Doing the algebra, 30 I1 is going to be equal to 20 times 18 is 360 minus 5, take it to the other side, will be 365 volts. So I1 is going to be 365 over 30 amps. In this approach of doing the problem, the current I that I want is just the same as I1, so I1 is 365 over 30 amps. Now, the result shouldn't be dependent upon where my constrained loop goes as long as it adequately accounts for the current through the current source. Let's choose a different constrained loop and see if we get the same answer. So the only other choice I can make is to have my constrained loop go out around here, and here it's still going to be 18 amps. It still accounts for this current. Now my mesh current, I1, hasn't changed, so I still get KVL. Still going around I1, I have a minus 5 volts plus 20 ohms. Now the only current going through the 20 ohm resistor is I1 plus 10 ohms. But now I have I1 going through this resistor, and I also have 18 amps in the same direction. So that's I1 plus 18 amps. That brings us back to our starting point. That's 0. 10 times 18 is 180 minus 5 is 175, so the algebra makes this 30I1 is equal to negative 175. So now my mesh current I1 is negative 175 over 30 amps. I've got a different mesh current than I had before, but the mesh currents are not physical currents in the circuit. In order to get this actual physical current I have to account for all the currents that contribute to that current. So my constrained loop now goes through this 10 ohm resistor. I have to take that into account when I find I. So now I is going to be I1 plus 18 amps, which is minus 175 over 30. 18 times 30 is 540. So now my current I is 540 minus 175, which is 365 over 30 amps. And the actual physical current is the same regardless of how I define my constrained loops.